Welcome everyone to this session, which is looking at stats. Okay, stats is one of those chapters that they are easy flowing if you understand the language. Okay, it's not much of calculations as you would see with other chapters. So with this one, I am going to be taking you through on the qualitative aspects of stats, the theoretical backgrounding. Once you understand the theory behind these key themes, it's easy to apply those ideas in any context. Then the next session is going to be looking at the actual questions, but today's session is more of looking at the actual theoretical background, the language of how you look at stats. Otherwise, you don't need to be worried as long as you have an idea what we are talking about when we are looking at the special themes that are being identified there. And the first session is going to be looking at sampling. According to your notes, you need to be able to explain. Okay, the most important thing here, it is to explain how data is collected. So that is the basic object of learning. It's not to calculate or do what. Yes, there are a little bit of those little calculations, but what is important, the first section that I'm going to be taking you through is what is stats all about. Okay, how is the data collected? Okay, so the second step, the second section is going to be looking at the measures of locality, central tendency, and also the measures of dispersion. Okay, but I'm going to start with the first step. Okay, so the first step here, we are looking at we are looking on how data is being collected. Okay, so the themes that we are going to be covering for today are those 5. Okay, so the one for data collection is the one which is related to sampling. Okay, so the data handling cycle starts with one having a question. Okay, there's a problem that you want to investigate. There is a question that you go inside the situation that you have, and then once you've got that question, you go now and collect and collect data. Okay, so that is what we are going to be starting with, the data collection. What are the different types of doing it, data collection? And then we are going to move and look at, after you have collected this data, what do you do with it? You have to represent it in different graphs. There are box plots, there are bar graphs, there are pie charts. There are different kinds of graphs that you can represent the data that you have collected. So now we are going to be looking first at the aspects, the principles of collecting data, and then after collecting, be aware of them, being able to explain them. We are going to be looking at how they are represented, and then look further on the data exploration. The data exploration now is when we are doing the calculations, and then after you have done data exploration is where you are looking at how you calculate your mean, how you calculate your quartiles, and so on and so on. And then after you have those calculations and graphs, how do you interpret? What is it telling you? Okay, so you need to be able to interpret the results of your data, and then you are able now to answer the question that you started with. Okay, so That is a cycle of of data handling. Okay, so now we are going to start the most starting point that we start off with when we are looking at lento sampling. We say, okay, fine, what is the population and what is a sample? Okay, and now we say now the population is a statistical study of the entire group of individuals about the information that we want. Okay, if ever you want to gather the information about UNISA students, so if you are going to be collecting data from all of UNISA students, so you are looking at the population of all UNISA students. Okay, so the sample now will be the part of the population from which we actually collect information. We use the information from the sample to draw conclusion about the entire population. So now if ever you have a question about how UNISA students study, you look at the whole population. And now you said, okay, I'm not going to have time to collect all the data, the opinion of every UNISA student. Let me look at the students that are doing science. That is your sample. It is part of the population. So now that's how you define the sample. So most of the time we look at the sample because we don't have, as the researchers, there's not enough funding to look at the whole population. The population, you'll find that when they are doing census, they are counting us, all of us here in South Africa, then that's the population. Although Mina, on the previous census, I was never counted. I don't know why, because they didn't come to my house, but they represented the data as if we were all counted. But the idea was we should all be counted. Okay, so now these are the keywords that we need to be aware of. Is what is the population? Okay, what is the difference between the population and the sample? Remember, what is an object of learning in this section is for you to be able to explain. It's more of explanation. Okay, so that's why the today's session is more of talking, explaining these keywords. Okay, and now we also need to look at what is a simple random sample, and what is systematic sample, and what is self-selected sample, and what is a convenience sample, and then stratified sample. You've got bias. Okay, those are the keywords that you find in this section of data collection. The survey, the observational study, we may not go through all of them, but these are the keywords that you know. When you are entering a statistical discourse, you know, Guti, you expect those keywords. So now there's different ways of collecting data. Okay, you can, in methods, you can collect data through census. Remember census, so you know Guti is the one whereby they were counting the population of South Africa. It is a study that obtains data from every member of the population. So now if you get a question which is asking you to what is a census, it's related to the whole population. Okay, and then the sample survey. A sample survey is when the data is only collected maybe from people of Gauteng, not the whole of South Africa. Okay, so now that will be a sample survey. That is mostly you find on the, if ever you go to Stats SA, the website, you'll find that there is these keywords are very familiar. And then there's an experiment. An experiment, you mostly find it on those who are doing science, okay, whereby there will be a controlled group, okay, and then there'll be another group which is going to receive a treatment, any group or treatment. You find most of experiment a lab or the medicine. Maybe they want to test grandpa. they want to test grandpa ukuthi affect abantu kanjani. So now they'll have a controlled group whereby they give grandpa, and then they'll have another group that does not have that did not take grandpa. So now that will be an experiment. It's mostly done when you are at the lab. An observational study, it is the one whereby you are like you are more like observing the specific groups. Okay, so now observational study will be, most of us, the researchers who are doing qualitative research, we do observational study whereby we go in a specific context, we observe the behavior of the people. Okay, most of those who are doing ilento, who are doing qualitative study, will do an observational study whereby as a researcher you sit and observe, okay, and observe the behavior of the people that you are trying to investigate. And now let us look there. You need to be able to make a difference now. What is a census against the survey? Okay, so now these methods deal with the population attributes. It's more of bigger studies. So this is a bigger method of collecting data. And now the data source for the census will be the whole population. And the one of the sample will be the subset of the population. And then the advantages of the census is is accurate because you've got almost everyone, not 100%, but at least you've got an overview. If ever I'm going to be investigating UNISA students, if ever I'm going to be looking at 80%, at least I'm a little bit accurate to understand how are you feeling about the way, the support that you get. Whereas if I'm looking at only science students who are registered at UNISA, I will not be getting the overview of the feelings of the students of UNISA. And then mostly sample survey is used when you've got it's nice if ever you don't have enough funding and then you've got few resources. So now those are the two differences. Okay, and then the example, let's have this example. So what does the average student weigh? Okay, so if you are looking now at the census, okay, the census will be you weigh each and every UNISA student or all South African students. So it will be a bigger data collection. So now you are going to weigh each and every student, and then chances are you are going to be more accurate on the average weight of UNISA students. And then for a sample, you would weigh some. Okay, look at the language. Look at the language. That's why people who are doing research, we are always accused of always being careful with the way that we say things. We say it seems, it might. We don't want to be decisive because we have collected data using a sample. So now look at the questions. The minute the question is like a little bit hesitant, it's like you are weighing some. No, you're not weighing every. Then you know, oh, this is a survey. The advantage is it's cost less and it's quicker and it's easier, the sampling. Okay, now we are going to be looking at the sampling methods because that's what we've got access to, and there are different methods that are being discussed that you need to be able to differentiate and explain how they work. Okay, so now the sampling methods refers to the way that sample observations are chosen. So if I decide to say, okay, I'm going to go to UNISA and I want to collect data only from science students. So how, this is the how I collect that data, it is a sampling method. Okay, that's what is referred as the sampling method, it's the how. Okay, so now we are saying now the common features. So we call this kind of way of methods probability sampling methods. The common features of this, it is random sampling. You just have a sample, then you go to science students, and then you just randomly choose any any science students. Okay, so now that is a feature of a probability sampling method, and then it is using unbiased parameter estimates. So when you are going to be choosing anyone, you are not being biased towards a specific group. Okay, so now that's why these sampling methods, they are mostly preferred, because you are unbiased. Okay, you are not going to science students looking for a specific people, whereby you said, okay, I only want shorter people, or I only want people who are staying in Soweto. You are just being unbiased in the way that you are looking at, you are sampling. Okay, those are the features of the sampling method. So there are three main types of these. There's a simple random sampling, there is systematic sampling, and then there's stratified sampling. What are these? Okay, so a simple random sampling, the properties of them is you're looking at the whole population. Okay, and of N, or you may be looking at a sample size of a specific group, maybe of an engineering student or humanities student, and then all samples are equally likely to be chosen. Okay, those are the properties of simple random sampling. Okay, for example, the lottery, the people who are playing a lottery, you get n number, get n member get a number. Okay, numbers are mixed. I mean, you see the lottery, it's been a long time since I watched the TV for a lottery, because what happening that machine, the numbers are mixed. Okay, and then n numbers, and then they start to choose, it's 6 numbers, I don't know, 6 numbers or 5 numbers, and then there's a bonus, and then there are selected number, the selected numbers go in a sample. So those 6 numbers of a lotto, they would go in a sample. So an example of a simple random sampling would be the one that is related. Think of a lottery. You may think of other examples. Okay, think of other examples that they look similar to lottery. Then you know what you can identify and categorize those kind of sampling as simple random sampling. Okay, and then there's the one of stratified random sampling. Okay, the description of this is the population is divided into groups. Okay, based on some characteristics, and then random sampling within groups. So now within a random sampling, you start to put the population into specific groups. Within that groups, then you apply a random selection. Okay, a random sampling. Okay, so these groups, they are called stratas. Okay, the example of that will be the national survey. Okay, so the strata based on geographical area. Maybe you would say, okay, fine, I want to do a survey of South African whatever you want, what you want to survey, but you said, I want to be looking at the sample from different provinces. So now, the minute you group South Africa according to provinces, the provinces become your stratas. Okay, so now you've got a Gauteng strata, you've got a KZN strata, you've got Eastern Cape strata, and then you've got Western Cape. Those are your stratas, because this is the whole population, but you are categorizing it according to the provinces. And then once you've got those different groups, you go inside Gauteng. And then inside Gauteng, you do a random selection of anyone that you want to be researching upon. So now that is what we mean about a stratified random sampling. Okay, and then that is one example. And then another example of a sampling method is the systematic random sampling. The systematic random sampling is whereby you list every member of the population. Okay, think of the population of UNISA students, or think of a population of South African citizens. Okay, now what you do once you have listed every member of the population, you randomly select from the first kth elements of the population. Okay, and then you select every kth element. Okay, and then we are going to look at an example. Okay, if you want to conduct a job satisfaction survey, you create a list of all the employees of checkers. Okay, you've got that list, and then within that list, you survey every 10th employee. Okay, then in those ways also, okay, I'm going to start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then so I'll pick up the 10th one. Then you move from the 10th one, then you start counting, and then the 10th one, the following one, which is going to be the second group of 10, and so on and so on. So that is, as you are being systematic the way that you are doing your sampling. Okay, here is another example. Okay, so let's say you've got a population of 40 students, okay, in this school. You've got the 40 students in the school, and now if you are using now you want to use a systematic random sample of 8 students. Okay, so from these 40 students, you want at least 8. You want a sample. Okay, ufuna research only on 8 of these. But now, how do you choose them? Okay, so now what you do now, you said, okay, fine, you will be skipping your interval by 5. Okay, what you do, you take the 40, you divide it by the 8 that you want. That means you are going to be choosing every fifth student in the list. Okay, so now using a random number table, we choose a number between 1 and 5. Let's say we choose 4. Then when we start with student number 4, and then we pick every fifth student. Let's say you decide to, okay, fine, I will start picking up my first student. I'm going to pick up number 4. Okay, I'm going to pick up number 4. Then, because now, according to my systematic sampling, I am going to be choosing every fifth. That means from the 4th student that I started with, I'll be choosing every fifth. So now 4, and then every fifth student from 4 will be the 9th one. Then you are going to choose this one and say, okay, I want to observe you. Then you pick up this one and say, okay, you are coming to my you are going to be part of my investigation. Okay. Oh, my pen does not want to write. Okay, it is going to be the 9th, and then you move from the 9th, and then from the 9th, you're going to be counting the 5th one. So now you are going to be choosing every 5th one. Whoever is on the 5th position from the 4th one, that will be a systematic random sampling. Okay, there are advantages of doing a systematic random sampling, and there are disadvantages of those. You need to be able to explain which is the best method that you are going to be choosing. The simple random sampling is when you are looking at all samples, and then the chances are all the samples are equally likely to be selected. And if you are looking at a systematic random sampling, not all samples are likely to be selected. You saw, I mean, if you are going to be looking at at systematic sampling, you only choose a kth element. So now those are the difference between those two. Okay. So now let's say you need to be looking at the examples that puts you in a position whereby you need to differentiate. Okay, let's say you've got a question here. They say every fifth person walk out of the movie theater is asked to name their favorite type of movie. Okay, so now you are asking every fifth person. So you're counting good 1, 2, 3, 4, 5. You leave the others. You will count from the fifth person. Okay, so you ask them, good, they must just name their favorite type of movie. And then to identify that, you need to identify it with, is it a sample? And suggest a population from which it is selected. Okay, so here is the story. It's in the movies. Okay, so now you need to be identifying it, okay, from this scenario, this context, because these things are all about contextualizing the stories using the definition of the population, using the definition of a sample. So now here is the population. Now we need to identify what is the sample here, and then what is the population that is selected from. Okay, so from here we are saying now, the sample is every fifth person leaving the theater. Okay, so because you are looking at every fifth person, not all the people, so that means it is a sampling. It is a sample, and then you are using a systematic sampling because you are looking at every fifth person leaving the theater. So that is your sample. So the population will be all the moviegoers. Okay, so that is the population of everyone that is going to the movie, but you are only looking at the fifth person walking out of the movie theater. So now that's how you differentiate those when you contextualize the definition in a specific context. Okay, now this question is saying now you need to classify a random sample. So here you say every fifth person walking out of a movie theater is asked to name their favorite type of movie. As I've already pointed out, Guti, you are looking at the case element, every case element. So that is none other than the systematic sampling, because you are looking at a specific number, case element. Okay, so it is a systematic. The members are selected according to a specified interval. Okay, so now that's how you differentiate these types of sampling. So this is how you would go about to do data collection using these different methods. Okay. Here is another example. Now there are visitors. These are the websites. Ne? That is the population, the context. Let's not say it's a population. The context of the websites. Okay, so the visitors to a website are asked to complete a questionnaire about their favorite aspects of the site and what would be done to improve it. So everybody who's visiting a specific website, okay, so you ask them to complete a questionnaire. So now you need to be able to identify in this context a sample and suggest to Guti what is the population this thing is selected from, and then you need to classify whether it is a sample, whether the sample is a simple random, the one which is similar to the one of Iloto, Or is it a systematic, a self-selected, a convenience, or stratified? We have not spoken about self-selected or convenience. Don't worry about that. But e-convenience sampling, if ever you are interested to know what it is, e-convenience is if I were to collect data from you right now, you will be a convenience sampling because I've got access to you as we are talking right now. So that is a convenience. That is a convenience sampling. Okay. So a self-selected will be for you to just select yourself and say, okay, I want to be a part of this sample. That is a self-selected sample. So now you need to explain your reason. So now the first example is saying a sample is the people who complete a questionnaire. A population is people who surf the web and they are self-selected. That means they volunteer to be part of your thing. But when you read the story, nothing has said that people they've asked to be part of of the data collection. So number one, it is really it is just out. Okay, let us look at number two. The sample is people who complete the questionnaire. Okay, and then the population is the people who visit the website that looks convincing. It is a convenience. Remember, we said a convenience. It is volunteered to be included. Okay, a convenience is like I've got access to you. Okay, it is almost similar to number 8, but let us read further. A sample here is the people who complete the questionnaire. Yes, that is convincing to be according to the definition of a sample. And the population is the people who visit the website. So now everyone who is in the, yes, it is a population because the context here is the website. And then the people are self-selected. No one has a self-selected to be included there. Okay. Now look at the difference. Yeah, you know, instead, what is interesting about is now what is the difference between surfing the web and visiting? Okay, so now when you visit the web, the difference is you just go there. You just go in there and then you don't surf the web. So now there is a little bit of understanding how the website is working. So it means now you would need your dictionary if ever you don't know the difference. But I'm just visited the website, but have you Googled it? We are using a word Google here in South Africa when we are like looking for more information. Okay, let us look at number D. The people who complete the questionnaire, and then the population over the people who surf the web is a convenience, and then it's volunteered to be included. Let us look at the correct of these four. We are looking at the answer is number B. Okay, it is people who complete the questionnaire. Yes, we agree. The population is people who visit. If you look at who visit, and then because here they are saying visitors, they are not saying people who are surfing. So now the surfing, I'm not sure of that English. So surfing maybe is people who are like surfing through the website without going inside. I'm not sure, but you need to, before you answer these questions, it's critical that you are clear of the context. Okay, so now because here there is a visitor, and then here we are also looking at visitor, so this becomes the population. And then here is a convenience sampling because people that go and visit the website, the person who's going to be collecting data has got access to those people. So hence it is a convenience. Okay, and then people are volunteered to be there, so you've got access. So I think the better explanation of convenience is people are, when as a researcher, you've got access to those people. Okay, so now basically those these are the theoretical backgroundings of the three. In the next session, not this one, we are going to be looking at the examples now on how the questions can come about, looking at those. So most of this section that we've looked at is looking at the theoretical background. You need to be explaining here. It's not about doing calculations. It's more of explaining, see the difference and know the advantages and the disadvantages. It is more theoretical driven. Okay, the section that is not theoretical driven is the one that is looking now. Remember, we said you are starting with a problem, you go and collect the data. After you've collected the data using those different sampling methods, you've got your data. What is it that you do? Okay, you collect the data from different people. What do you do with that? You go and represent it into different representations. Okay, and then you need to be able now to even calculate the average. We call it average in our everyday language. That is measures of locality, and also you need to measure the spread, the dispersion. Okay, so we are going to be looking at standard deviation, but let us look at the learning outcomes. What is it that you need to do when it comes to presentations? We'll look at the presentations first, okay? You need to be able to know the difference, okay? It's still about knowing. What is the difference between qualitative and quantitative data? That is also theoretical driven. You need to know the difference between those keywords. You need to be able to draw up and interpret a frequency table. These things I'm reading from your notes. You need to be able to draw and interpret a histogram. You need to be able to draw and interpret a pie chart. What information is it telling you? You need to draw and interpret a cumulative frequency polygon, and you also need to draw and interpret stem and leaf plot. Okay, we may not be able to go through the exam related questions today. However, what we are going to be doing is to take you through the theory behind this. This section of stats is easy if you understand the language. Okay, if you understand the language, you don't need to be stressing about this. You need to be spending time on things that needs you to be doing more calculations, but we know Guti stats sometimes it's got jargon that is sometimes difficult to understand. Okay, so a mind map of the stats, I mean, it is something that looks like this. You can look at this mind map when we are looking at the copy of this presentation. I'm not going to go through this, but this is what I advise my students when they are doing any topic, especially a topic like stats that is more theoretical driven, to write the keywords and write the mind map of the things that they need to know, especially from the chapters that you are looking at. At least if ever you can draw up a mind map, it helps you to remember and explain concepts, because this is more of a conceptual a mapping of the stats. Okay, I'm not going to go deeper into this. You can just have a look and see if ever is the better way of learning, especially the topic of stats. Okay, so we are saying now stats is a tool for converting the data into information. Remember, you've gone out to collect data using different sampling methods, that is stratified, created demonstrators, or it was a systematic sampling, or it was a random sampling. Any of the methods that we have done, you do have this data. Now you want to put this thing into information. So what? Who cares about this data that we've collected? So now you need to put that into an information. Going back to a cycle, we are at a stage whereby we are going to go between representation of the data, how you interpret it, and then also data exploration, those two. Okay, data exploration is more of looking at the calculations. Okay, so let us look at the data exploration. It is data-centered query and analysis. Okay, you are exploring the data using graphical and numerical techniques. Okay, when we say graphical, is you are looking at the different figures, shapes, our frequency tables or histogram. How do you look at this and interpret them? Okay, and now the basics of this that are built in this is the central tendency, is the variability, is the position. Okay, the position is about the quartiles. Okay, so those are the things that we are going to be looking at. Okay, so now when we are looking at the central tendency, the central tendency mostly is when you're talking about the average. Okay, that's an everyday language. The average, and then most of the measures of the central tendency, it is a mean and also the median. Okay, there's also a mode. Okay, a mode is when we'll go through on what mode is, but those are the three ways of calculating a central tendency. And then in mean, the formula of the mean is looking something like that. And then we are saying now when you are computing the mean, okay, when you are computing the mean, you add all of the data sets, all of your numbers, you divide by the number of the bits of the data, the number of your data set. Let's say, for an example, you've got this data, and then how many is 1, 2, 3, 4, 5. So you add all of these and then you divide by the number 5, then you get the mean. Okay, that will the mean is measuring the average, but at least on average, because the average is always the better way of getting it or of getting a sense of your data. Okay, and then there is immediate. Okay, median, Yona, is the middle is the middle number of an ordered list. Ne? This is what is important, is the ordered list. Okay, you need to order your list from in an ascending way. You start with a smaller nyana one and then you go. So let's say you've got this, you need to find the median. Okay, so now you've got 2, 4, 6, 8, 12. This data set is ordered. Every time when you are going to be calculating for a median, make sure that it is ordered. What we mean sometimes by that is when you've got 2, 4, and then you've got 1, and then you've got 0, and then you've got 5. Okay, let's say you've got, before you can calculate a mean, you need to order it. What we mean by that, ordering it means you're going to start with a smaller nyana one and then follow in an ascending order. You order your data set. Then after you've ordered your data set, now there are 2 ways that you have to focus on when you're calculating the mean. If your mean is, if your data set is odd numbered, you've got odd. The odd is when you've got 3, that's an odd number, 3, 5, 7, 9, you know, those are the odd numbers. So if it's odd numbered, it's not a problem, you go to the middle. Okay, you go to the middle to get here, to get your median. But if it's even numbered, you go to the 2 numbers in the middle, you add them and then you divide by 2. Let's look at those scenarios. Let's look at this one. This one, it is 1, 2, 3, 4, 5. This is odd numbered. So if it's odd numbered, it's not a problem. First thing, it needs to be ordered, and then if it's ordered, now you're going to look for the middle one. So uno 2 ngapha, and then you've got 2 ngapha. The one in the middle becomes your mean, your median. Okay, so let's look at another one. You've got this one. This one, it is you need to find the median, Remember, we are saying before you find your median, you need to first order your list. So now ordering your list, you're going to have 2, 4, 6, 8, 10, 12. Because this one was not ordered, so you put it in an ascending order. Okay, starting from the smallest one to the highest. And then you first have to calculate how many, the number of your data set. It is 1, 2, 3, 4, 5, 6. This is even. Okay, you've got even numbered. This one was odd numbered. When it's odd numbered, you just go to the middle. Because now this one is even numbered, you go to the between the two. Let's part these two, okay? These two becomes your middle terms. Then you add these two and divide by 2, and then you're going to get a median. Okay, we are going to see how these plays out when we are doing our calculation. So you need to first look: is it odd or is it even numbered? If it's even numbered, you look at the two middle numbers, and then you add them, and then you divide by 2. Then that's how you get your median. Okay, so here is it's just pros and cons. And cons, that means advantages and disadvantages of choosing either of the two. If ever you are going to be choosing, remember, as the researcher, you can choose any way of calculating the measures of your locality. You can choose median, you can choose the mean. It's really up to you. Okay, so but we are saying if ever you are going to be choosing a mean, okay, if you're going to be choosing your mean, you must know into your mean is going to be changed drastically if ever you've got what we call an outlier. Okay, and what is an outlier? You are going to come across the keyword outlier. Outlier, it is that number that is misbehaving. Okay, it is not behaving the same way, uniform way as the other numbers. Okay, look here, you've got 65, 70. So these ones, they are very close to each other. But now look here, you've got 0. The gap between 0 and 70 is too wide. But the gap between 70 and 75 is not that wide. These are the friends. These are the neighbors. These are the neighbors. So they are almost behaving the same way. But there's a wide gap. That means 0 is an outlier. Okay, once there's an outlier, if ever you are going to be using the mean, okay, so the mean when there's no outlier, it is 83. But once you add this outsider, okay, a black sheep of the family, once you add a black sheep of the family, the mean is going to be affected. Look at the mean. It was 83 when there was no black sheep. And then now once you put a black sheep of the family, the mean changes. It gets affected. Okay, but the median does not change. Median ayinankinga. Whether ufaka a black sheep of the family or what, it does not get affected. Okay, so now those are the disadvantages of using either one. Okay, so these are the things that we try to, when you're answering these questions, do some interpretations. Okay, and then we also speak about the variability. That means the spread of your data. So now we talk about the variance. We also talk about the range, and we also talk about the standard deviation. Okay, guys, I think I'm going to come back to this, ne? Let me come back to this. Oh, I can quickly do it for 5 minutes because now I want to take you through the different charts. But let's look at the range. A range is when you put your data set from the lowest to the highest. Okay, and then you take the highest number, you subtract it, you subtract the smallest. That's what range is all about. It's a measurement of the variability. First, put your set in an ascending order, starting with the smaller one to the highest one. That is a range. Okay, so the range, it is sensitive to the outlier. Once you start putting a black sheep of the family that is an outlier, it gets affected. That is the sensitivity. It is sensitive to the outlier. So if you know what you've got a black sheep of the family in your data set, you would not want to be using Ilento. You don't want to be using Ilento range to calculate variability. And now there is variance. Variance, there's a formula. We are going to be looking at this for details when we are doing the calculations that are related to variance. I'm just throwing these to you because I want to quickly move to the graphs and how you interpret them. Okay, there's also a standard deviation, which is also the measure of the variability. It's also got a formula. You don't need to be stressing about doing the calculations with your head. Even the calculator can calculate for us standard deviation without doing it manually. And then I want to speak about the quartiles. Okay, the quartiles is when you divide your data set into 4 equal parts. Okay, so now the values are divided into what we call the second, the third quartile, and they are denoted with Q1, Q2, and Q3. Okay, the second quartile, that's the name of it. It is the 50%. That is the median of your data. So when you see that they're talking about the second quartile, that is 50% of your data set. But the first quartile, that is the 25% of your data. And then if ever you are talking about the third quartile, we're talking about of your data set. We will look at that when we are doing calculations. I am just throwing to you these keywords. Okay, so then when I'm starting to refer to the quartiles, you know when we are interpreting the graphs. Okay, and then I'll come back here. This is where I want to be. Okay, so now the charts and the graph, it helps you to look at the patterns in the data. We are going to be looking at histograms. We are going to be looking at stem plots. We are going to be looking at box plots and also cumulative plots. We are not going to look at scatter plots. It's not what you are expected to do. So you don't need to be worried about that. I'm not going to do it. It's just that it is just showing you the different types of the charts that you can find. And then let's look at this one. Now the patterns, remember we've spoken about the center, the measures of the locality, the spread, aboma range, the shape and the features of your charts. So now we've got the center will be what you find in the center. So now this is a histogram. I will explain to you what is a histogram. How do you differentiate it between a histogram and a bar graph? So now this is the center where your graph is, your chart is dividing into half. So now that will be your center, and then here this will be the spread, how your thing is spreading out. We mostly use in the charts, the range. So if ever you are given the charts and then you are asked to analyze the spread, you just look at the range. That means you take the highest number, you subtract the lowest number. Okay, and now the shape, there are different shapes of this. There is a symmetry, there are a number of peaks, there is skewness, and there's uniformity. Okay, so the symmetry is when your graph is looking like this, it's bell-shaped. It is more symmetrical. That means when you look in the middle, you can visibly see the middle, and then there's the left and there's the right, and the middle is symmetrically. So now that's how you would describe the shape of your data. Okay, so now we are going to be looking at the skewness. Okay, the skewness, this one is right skewed. It is right skewed because there's a lot of data in the left, okay, and there's little to the right. So now we are saying it is right skewed. Okay, so now that's how you would, if ever you are asked to interpret the shape, when it's right skewed is when there's little to the right, then you're saying it's right skewed, and then the left skewed is when there is little to the left, then they're saying it's left skewed. That's interpretation of the of such shapes. And then sometimes you find that you've got shapes that has got so many peaks, like this one. This has got 2 peaks. You've got that peak, and then you've got that peak. So now it is called bimodal. Okay, and then you look at the one which is uniform. Uniform is mostly very nicely smooth. Okay, that means you've got a uniform a shape of your chart. And then sometimes you've got unusual features. That means gunama gap between your shapes, or gunama black shapes of the family that is sitting right there in the end alone. So that will be an unusual feature. This one has got a gap. It's an unusual feature. Those are those are things that you use to interpret your shapes. Okay, an outlier is when there is the person sitting right there. Look at this one. This one, everybody is close to each other. They are neighbors, and then Yona is sitting right. So now you would interpret that shape as it's got an outlier. Okay, it's got that is behaving in its own way. Okay, so now let us look on how you describe the data, and mostly we're going to be focusing on a stem plot, the box whisker, that is a box plot, and also the histogram. Okay, so I will look at this when we are doing that description. Okay, and then let us look at these two. Okay, you first have to differentiate between a bar chart and a histogram. Okay, so these are different ways. Okay, a bar chart is made up of columns plotted on the graph. Okay, the columns are positioned over the label that represent a categorical. A categorical could be categories, maybe a color, or mostly I'll be using in color. You've got yellow, blue, pink. It is more of qualitative. Okay, the names of things. Okay, so now a bar graph looks like this. Okay, it is you've got qualitative. Okay, qualitative is like a difference between qualitative and quantitative. Quantitative are the numbers that you can calculate. Qualitative are the names of things. Okay, maybe it is January, February, March, or it's the colors. Those are described as qualitative variable. So this is a bar. A bar graph, and the bar graph has got spaces in between. You see that there are spaces, and the way that you define it, it is quantitative against qualitative. Those are the features of a bar graph. There are spaces between these. There are spaces between these. It is qualitative against quantitative. However, the histogram, it is a different one. A quantitative against quantitative. Okay, it is, but it's got columns, and the columns, they are close. There are no gaps between them, and they are positioned along the quantitative variables. Here is an example. Okay, look at the histogram. Without being told, you know, this is a histogram. Agunama spaces in between. There are no spaces in between. And then here you've got quantitative. Here you've got quantitative. Then you know what you are working with a histogram. Okay, so now that's how you differentiate those two. Okay, we are saying a bar chart. A bar chart is qualitative groups, because at your x-axis you've got qualitative, and then it can be the symmetry. Those features of symmetry and skewness are not used. There are space between the columns. That means there are gaps with a bar chart. With a histogram, it is quantitative, and then you use all these features, or skewness, no length, or no symmetry, and then there are no spaces between the columns, and there are no gaps. Okay, and then now the most interesting plot is the stem and leaf plot that you need to know how to interpret. Okay, here the stem plot, it is displaying a quantitative. Remember, we are saying quantitative data is the one that has got everything to do with numbers. You do calculations. Okay, so here the stem and leaf plot looks like this. Okay, so now when they are talking about stem and leaf plot, they are talking about something like this. Okay, so now let's see, how do you create a stem and a leaf plot? Okay, here's an example on how you would create stem and leaf plot. Okay. Okay, the way you would you would interpret this, how you do this is, you've got a data set. This is a data set that is given to you. Okay, so in this data set, the first step that you do if you want to create a stem and leaf plot, you need to put all of your data set in an ascending order. You start with a small number and then you increase in an ascending order. So now this one was not in an order, so you needed to put it in an ascending order. So the first step, you put it in an ascending order, and then we are going to go to kunama tens, kunama digits is 11, 12. So now these are digits about tens. So these are the 20s. There's only one 20s. These are the 30s. So these will be grouped together. These are the 40s. These can be grouped together. These are the 50s. You can group them together. There's only one 60s. There's only one 70s. There's this group of 80s, you can group them together. There's a group of 90s, you can group them together. So a stem and leaf plot is when you have a stem, nama leaves. Okay, so now look at this. These are the tens above 1 love. Okay, when you write them, they start with above 1, here above 2, here above 3, here above 4, here above 5. This one is 6s, this one is 7s, this one above 80s, and then this one above 9. Okay, these become your stems. Okay, so now you write your stems in this way. Above 1, 2, 3, 4 is 1, 2, 3, 4, 5, 6, 7, 8. These becomes your stems. Okay, so now let us start with your leaf. Okay, starting with the first group. Lawa above 1, you've got the first group, my stems go 1. So the 11 has got a stem of 1 and a leaf of 1. Okay. Ulento U12 has got a stem of 1 and a leaf of 2. There is the 2. Okay. U16 has got a stem of 1 and U6. So now that will become the leaf. Okay. U24 has got a stem of 2 and a leaf of 4. So you write your leaves on the right hand side. Look at this group. Now 1, 2, 3. So now you've got a stem of 3, and then your leaves is 2, your 7, and your 8. So now you write here, it is 2, 7, and your 8. And then U4, it is 43. Your stem is 4. And then you've got ama leaves, U3, no 7. So now you write your 3 and your 7. And then U54, you've got U5. This is your 54, this is your 56, this is your 57. Okay, and then U60, there's your stem, and U1 is your leaf. Your 75, you've got 2 is your stem, U5 becomes your leaf. And then if you are on U80s, you've got 1, 2, 3. Okay, you've got 83, you've got 86, you've got 89. That's how you read your stem and leaf plot, and that's how you would construct it. Okay, kuma 90s une stem esingu 9, your leaves will be 2, will be 3, would be 6, would be 7, would be 9. Okay, so now that is going to be your leaves. Okay, so the way that you would read this, look at the key. The key is saying your stem is 2 and your leaf is 4. So you read it as 24. Okay, so now that's how you would read this one as 24. If you want to read 57, you are going to have your stem of 5 and then the leaf of 7, and then this one becomes a shape now. Your leaves becomes the shape of your stem and leaf plot. How do you interpret these? Okay. How do you interpret these? Okay. So now you've got, let's suppose that someone has been selling their old baseball card collection online, card by card. Okay. They have kept track of all their sales so that and plotted them in a stem and leaf plot. Okay. So now your stem and leaf plot has been plotted for you. Okay. So now what you need to do is to interpret this, because that's important for us to interpret this. Okay. So now the question is saying, how many cars have they sold? Okay. If you look at this, look at the stem, you're starting with your 3 and then you end with your 15. So now how many cars have they sold? They are saying now these are all the cars that are sold. They've sold all of these cars that are on your leaf. So how many cars have they sold? What is the lowest sale price and the highest? That means you need to look for the lowest number, and also you need to also calculate the median sale price. Okay, so now we are calculating a median of the charts. Okay, let's look on the question. Okay, so now how many cars have been sold? That means how many sold, each and every, how many numbers do you have your leaf? Okay, so now for you to be able to calculate how many cars have they sold, you need to calculate to how many leaves that are there. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14. All of these you had count them. So until 24. So now they have sold 24 cards. Okay. So now that's how you look at, you answer the question of how many have they sold. You do a head count of your leaf. Good, how many are they? How many numbers do you find there? Okay, and now this question is saying, what is the lowest sale price? Okay, so remember how you read this thing. You read it from here. This one will be, whenever you were to write these numbers, if you were to rewrite these numbers as the whole data set, you will start and say, I've got 34, I've got 34, I've got 35, I've got nothing at 4, I've got 52. So these are the numbers of your data set. So this will be your 61, this will be your 61, this will be your 62, and so on until 150. Okay, if you were to take your stem and leaf plot and write it down from as the data set. So now the question is saying, what is the lowest sale price? This becomes the lowest sale price, because if you were to rewrite these, not in a stem and leaf plot, the lowest number would be 34. Okay, and then what is the highest? The highest will be 150. That means this last number becomes your highest. So now if ever you were asked to calculate the range, okay, your range will be equal to 150 minus 34. That will be your range. Okay, so now that's how you would be interpreting a stem and leaf plot. Okay, so when we are looking at the exam related questions, when we get to this stage, you will see how useful this theoretical backgrounding will help us when we're looking on such examples. Okay, so now how do you calculate a median when you are given ilento? when you are given a STEM and lift pro. Okay, so how would you calculate median? Remember what we have said. We have said we calculate the median. Yeah? A median, we calculate it when we have put everything in order. All the numbers have been put in order. We have identified that because this is 34, 34, 35, 52, 61. These are all the numbers. And then we've got 24. Okay. Remember we said when you've got 24, okay, 24 divided by 2, that means the middle numbers, when you divide 24 by 32, the middle numbers will be between 12 and 13. Okay, so now between 12 and 13, that is going to be the numbers that you are going to extract. Okay, you are going to extract those numbers. And then you're going to extract those numbers, the 12th position, okay? You look at the position. So the 12th position and the 30th position, those are the numbers that you use to calculate your median. So now how do you read those, okay? Remember, you start with your stem. You start with your stem, which is 6, and then 5. That is your 12th value. So now that's where you get your 65. And then you also look at your 13th position, that is your 72. So you add your 72, then you get your median. So now that's how you will be calculating your median when you are reading off a stem and leaf plot. Okay, you can also say further and say this one plot the features of your stem and leaf. Okay, so but you were not asked that, you were asked for a median. So that's how you would be interpreting the median. And then what about the mean? Okay, we know the mean. The mean, it means you would have to add up all of the 24 members of your leaf and divide it by 24. That means for you to calculate the mean, you would have to say 34 plus 34 plus 35 plus 52 plus 61 plus 61, all of them until you reach 150, and then you divide these by 24, then you will get the value of your mean. Okay, so the mean you would have to calculate it manually. Okay. Here's another example. This stem and leaf plot shows the grade point averages of 18 students. Why do you know it's 18 students? You can count. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18. Tell from analyzing your stem and leaf plot. And now you have to calculate the average, what is the range of the stem and leaf plot. Remember the range, you start with the smallest one plus 4,0. Okay, so now you're going to have your maximum. Your maximum mark is 4.0. Minimum is equal to 0,8. So your range will be equal to 4,0 minus 0,8. Okay, so now here is the calculations where you would get your calculations. Let's say what is number 2? How many students have a grade of 2 or more? Okay, so now here is someone who's got a grade of 2. Okay, this is 2. Okay, so now this is 2.0, this is 2.4, this is 2.5, 2.6. Okay, how many have a grade of 2 or more? Okay, 7 plus 4. Where is the 7? 7 plus 4 plus 1. Okay, so now you would have to be calculating everybody that has got a mark of 2. That means the first group will be 1, 2, 3, 4, 5, 6, 7. There are 7 students here, and then 1, 2, 3, 4. There are 4 students here. There's 1 student, so total 40. Okay, so now if you were to add this one, you've got 7 plus 4 plus 1. So now you've got 8, 9, 10, 11, 12. You've got 13 students that got 2 or more. What is a mode of the grade? A mode is the number that is appearing so many times. Okay, so you've got this one is appearing so much. You've got this one that is appearing so much. So here you've got 2 modes. Okay, you've got a mode which is 4, and then you've got a mode of 5. So there are 2 modes here. Okay, there are 2 modes, 1.4 and 2.5. So now it is 2.5 and also 1.4. I was pointing it to a leaf, but the way that you read this, you read it as a leaf and a stem and a leaf. Okay, the cumulative frequency. The cumulative frequency, we are going to delve into all of these frequency, all of these graphs when we are doing the exam related questions. Right now, I was just laying background on different aspects of the theory that is behind the stats. Okay, so the cumulative frequency plots, it is a way to display cumulative information graphically. It shows the number, percentage, or the proportion of observations that are less than or equal to. Okay, less than or equal to, that is critical. What is defining this? What does that mean? Okay, let's look at this. Okay, let's look at this example. Okay, in this example, you've got a frequency of people. Let us look at this table. You've got a frequency of people that are weighing between 0 and 2 kgs. That is there's a frequency of 2. The cumulative frequency will be the same as the frequency on the first line. Okay, and when you calculate ilento, and now you are told the frequency of people that are weighing 2, I'll say kilograms because we are not using this. This is an American measurement. So people who are weighing between 2 and 4 kilograms, there are 17 people. How do you write a cumulative? You add the previous cumulative to get this one. Okay, so now you are saying 17. Okay, 17 plus 2, it gives you 19. Okay, now let us look on this one. This is the data now you are collecting. The people who are weighing between 4 and 6, there are 24 people. How do you get a cumulative? The previous cumulative plus this one would give you this. Okay, so now you're saying 19 plus 24 is giving you this. That's how now you are generating your cumulative frequency. So now the people who are weighing between 6 and 8, there are 23 people. How do you get a cumulative frequency? You take the previous one, the 43, you add the current frequency to get your 66. Okay, so now the people who are weighing between 6 and 10, okay, you are told is 10 people. To generate the cumulative frequency, you add the previous cumulative frequency and this one to get this one. That's how you calculate this. And then the people who are weighing between 10 and 12, there are 4 people. That's what is given. How do you calculate the cumulative frequency of these people that are weighing between 10 and 12? You take the previous one, cumulative frequency value, you add the frequency, so to get this one. So now the cumulative frequency graph would look like something like this. Okay, So now on your x-axis, that will be the weights. That means this will be your weight. And then on your y-axis, that is going to be your cumulative frequency. And then it gives you this nice shape. Okay. And then here is saying now, 5 people. This question is saying how many babies were born weighing less than, okay, less than 5, let's say, kilograms. We know what babies do not weigh that, but we don't want to be using American ways of measurement because we are going to be lost in the context. Let's say it is 5 kgs. So now we are saying you've got 5, you start from 5 and then you go up and then you draw a ruler and then you are going find that it is 30. Okay, so now that's how you would be answering the question, how many babies were born weighing less than 5 kg? That means you start from 5 and then you go up, that is going to be 30. Okay, let's look on another question. Okay, here is the question of the students. Okay, you are given the number of students, which is here on your y-axis. And you've got now the marks of the students. Okay, and then here, this is a cumulative frequency. It's been drawn for us. It's a cumulative frequency. It's already been drawn for us. We did not need to draw it. What we need to do is to interpret it. The question now is saying, how many students got between 50 and 70? Okay, so now how many people got between 50 and 70? So now the way that you would do it, you are going to say, okay, fine, you are looking for 50. This is not straight, ne? So now if you were to draw a line from 50 going up, you are going to find that it's between 10 and 20. It is 15. There are 15 students. Okay, there are 15 students who got 50. Okay, and those that got 70, you take 70. That means if ever une ruler a right, okay, so now you are going to have 70 where it interacts there, where your line intersects, that is going to be 30. So now there is your 30. That is your should be your 35. That is your 35. If ever we were drawing correctly, I'm not using my ruler, so seemingly this becomes your straight line. So this becomes your 35. So now you've got 35. You said you are only working with this. This is your 35. So you're looking for the number of students. So you're going to have 35 minus 15. So 35 minus 15 is equal to 20. That means 20 students got between 50 and 70. So that's how you interpret the cumulative frequency. This one is how you draw. Okay, this is how you draw a cumulative frequency. You draw it from the frequency data. Okay, you draw it from the frequency data, and then you will have you are going to be having your cumulative frequency against your weight. Okay, the frequency, it helps you to get your cumulative frequency. Okay, this is how you will produce. But this question is when now you've got the graph, and what you need to do is to interpret it. Okay, this one is saying how many students got at least. Okay, there is an issue of interpreting what do we mean or at least. You saw that when you were doing linear programming, there was an issue on how you use at least. Or at least when you're listening, most of us who are using a castling, or people will say, maybe when people have died, someone is going to say, at least Shem, kushone few people. That's how we talk. But at least does not mean little, guys. I mean, if you listen to the news, they will say at least 3 people died. And then you will say, at least, I mean, I also use that language. My mind is always thinking at least is something that is small. But mathematically speaking, at least means more. Okay? At least means greater than or equal to. Okay, when you are listening at the news, they like to use this term. They say at least 10 people died. They say there is more than 10 people that have died. Okay, it does not mean no, there's little. No. It is more. So once you see a word saying at least, it means we are looking for people, how many students who got more than 70%. Okay, so now what you do, you go to your thing and say, okay, fine. The people who got more 70%, so you've got your 70, you come, you've got your 70, you draw your line, okay? So now the people who got 70, you've got 35. This is your 35, okay? And then there is a maximum. We are saying we are looking at least, that means we are looking for people who got greater than or equal to 70%. That's what at least means, okay? At least greater than or equal to. That means you are going to start with your 70, you've got 35, abatole 70, and more above here, okay? So now the number of students, it is 50. You've got 50 students, and then you've got here, you've got 35 who got 70. So now, how many? You are going to have your 50, okay? You've got your 50 students minus 35. So your 50 minus 35 is going to give you 15. That means there are 15 students from here, Gula Point, going there. There are 15 students abatole greater than or equal to 70. So it is very important we know what we mean about a thing which is saying at least. At least it means we are looking at more, okay? It is more, greater than, or equal to, okay? So this is where you would we would be caught up, okay? So there's also a section whereby you need to be able to interpret the quartiles. Okay, so I'm throwing the theory behind this, so then when we do the exam related questions, we know what do this mean. Remember, I've earlier pointed out what do we mean by quartile 2. Quartile 2 is the median, that means the middle. We know how to calculate the median, okay? I've taken you through on how you calculate the median. That means it's the 50% of your sample. Okay, and then we have taken I've pointed you out to a quartile 1. Quartile 1 is telling us 25% of your data set, and then quartile 3, it is about 75% of your data set. Now let's say these two are being combined in a context of a cumulative frequency. Okay, so in a context of a cumulative frequency, let's look at how you combine the quartiles and the cumulative frequency. Okay, so the box plot has been, I don't want to be drawing a box plot. I just want to show you how you look at, how you interpret the range, how you interpret the median, how you calculate quartile 1, how you calculate quartile 2, how you calculate quartile 3. Okay, so now we are saying now that okay, it's power saver. Okay, the shortest plant, when you interpret your cumulative frequency, this is our cumulative frequency. We are looking at this one. This is what we are focusing on. We are focusing on this one. We want to interpret it in relation to the range, median, quartile 1 and quartile 2. So now the shortest plant here, the shortest plant here would be 8. So now how do you get your 8 is when you start from here, and then you start from 10, and then here this becomes the number that you are looking for. And the tallest one would be when you look at the cumulative frequency, the highest one, that would be your cumulative frequency. No, this is an information. This is an information. You are given this information. This is, you are told, this is your shortest, this is your tallest. We don't need to be calculating, it's given. So now you are asked now to calculate the median. Okay, so now how do you calculate your median? You calculate your median by taking the highest from here, from your from this side. Okay, so now here you've got your 80. Okay, to look for your position, because to calculate for your median, you need to know where is the position of your median. So to get the position of your median, you take your 80, that is the n number, and then you divide it by 2. You find that your median is going to be at the 40th position. So this side of the cumulative frequency gives you the position. So now the 40th position, how do you get it? You take your maximum on your cumulative frequency on your y-axis, you divide it by 2, and then you say on your 40th position, you draw up your ruler, okay, and then towards down to your x-axis. This was just a theory behind on what we are going to be doing on the next session. The next session is going to be on application of the theory that I've discussed today. So we are signing out for this session.